whole square or a minus b whole cube. Now using these identities, if I will ask you to find out the value of 98 raised to the power 2 or 101 raised to the power 2, you can easily calculate using these identities. For example, this 98 raised to the power 2 can be written as 100 minus 2 whole square, and this 101 raised to the power 2 can be written as 100 plus 1 raised to the power 2. So using the identities a minus b whole square or a plus b whole square, you can calculate this values very easily. Now my question is to calculate the value of 98 raised to the power 5. And when you have to calculate the value of 98 raised to the power 5, which can be written as 100 minus 2 raised to the power 5, now you need to use repeated multiplication here, which will take a lot of time to calculate the answer. Now to overcome this difficulty, we can also apply a theorem which is called as a binomial theorem, and this theorem will help you to calculate or to find out the expansions like a plus b raised to the power n, where n is some positive integral value or it can be a rational value. So in this chapter we are going to learn about a binomial expansion. We are going to learn about a binomial theorem which will help you to expand a plus b raised to the power n. Now let us have a look at the identities which you have done earlier in the lower classes. A plus b raised to the power 0 can be written as 1. A plus b raised to the power 1 is a plus b. A plus b raised to the power 2 can be written as a square plus 2ab plus b square. A plus b raised to the power 3 is equals to a cube plus 3a square b plus 3a b square plus b raised to the power 3, and a plus b raised to the power 4 can be written as a raised to the power 4, 4a raised to the power 3 into b plus 6a square b square plus 4ab cube plus b raised to the power 4. Now if you will look at these identities very carefully, you will observe something. What we have observed here is the number of terms this side is always 1 more than the index. For example, here the index is 0 and the number of terms this side is 1. Here the index is 1 and the number of terms this side is 2. Here the index is 2, number of terms this side is 3. Index is 3, number of terms this side is 4. And when the index is 4, the number of terms this side is 5. So what we have observed is the number of terms in the expansion is 1 more than the index. Second thing what you can observe here is that the power of the first term is keep on decreasing. Like here the degree is 2, here the degree of a is 1 and here the degree of a is 0. Whereas the degree of the second term, which is b, is keep on increasing. Here the degree of b is 0, then degree is 1 and here the degree of b is 2. In this expansion if you will see, the degree of a is decreasing 3, 2, 1, 0, and the degree of the second term, that is b, here it is 0, 1, 2 and 3. So degree of the first term is decreasing and the degree of the second term will keep on increasing. Now the third thing which you must notice over here is that the sum of the indices of a and b, sum of the indices here 3 plus 1 4, 2 plus 2 4, 1 plus 3 4, here 4 plus 0 or here 0 plus 4 is 4, whereas the index is also 4. In the same way, in this expansion if you will see, the sum of the indices 2 plus 1 or 1 plus 2, or here it is 3 plus 0 or 0 plus 3 is 3, same as this side the index is 3. So the sum of the indices is equal to the index of a binomial. So now let us write down the index and the coefficient of these expansions. This side we'll write down the index and here we'll write down the coefficients. When the index is 0, the coefficient is 1. When the index is 1, the coefficient is 1, 1. When the coefficient, when the index is 2, the coefficient is 1, 2, 1. when the index is 2, the coefficient is 1, 2, 1. When the index is 3, the coefficient is 1, 3, 3, 1. Index is 3, coefficient is 1, 3, 3, 1. When the index is 4, coefficient is 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Now, if I will ask you, what is the extension of a plus b raised to the power 5? It will be a little difficult for you to find out because then you need to use repeated multiplication. You have to multiply a plus b raised to the power 5 with a plus b raised to the power 4. It will be time consuming. Why not we use this pattern which we have written over here? The pattern, if you will see carefully, on the first number, the topmost number is 1, and to the extreme right side and left side, the numbers are written 1, 1. And the remaining coefficient, how we can obtain it? Like 1 plus 1, 2, 1 plus 2, 3, 2 plus 1, 3, 1 plus 3, 4, 3 plus 3, 6, and 3 plus 1, 4. This is how we have obtained the remaining numbers. Same way, if your index is 5, you can find out the coefficients. Like in the extreme right side and left side, we write down the number 1. Here 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. Now the coefficients are available with us. And the pattern is also available, whatever we have observed over here. So using that one, you can write down the expansion for a plus b raised to the power 5. And also children, the triangle which you can see over here, this triangle is called as the Pascal triangle because the arrangement of numbers is written in a very special way. So this is the Pascal triangle, and using Pascal triangle you can find out the coefficient of any binomial. Now here using these coefficients, I will write down the expansion for a plus b raised to the power 5, which will be equals to a raised to the power 5. Then the next coefficient is 5, so 5 a raised to the power 4 into b. Coefficient next is 10, so 10 into a raised to the power 3, b raised to the power 2. Other coefficient is again 10, a raised to the power 2, b raised to the power 3. Then 5, a into b raised to the power 4. And the last coefficient is 1, so b raised to the power 5. So using the Pascal triangle, we have find out the new expansion, that is a plus b raised to the power 5. So we have used the Pascal triangle to write down the expansion of a plus b raised to the power 5. Now, my question is to find out a plus b raised to the power 7 or find out what is the expansion of a plus 2b raised to the power 16. Now it will be little difficult because what we have to need to do is, now in the Pascal triangle we have to write down all the rows till we'll reach the index 16, and it will be a very lengthy process because if I will increase the power to 100 or 200 or some other higher power, then is it that you are going to write down the Pascal triangle till you will reach to the required row? It's not required. So why don't we find out certain rule which will help us to find out the expansions of a binomial of any power. For that, let us take the help of the combination which we have studied in the earlier classes, just to write down these numbers which we have used in the Pascal triangle. Now using the help of combinations, we have written the Pascal triangle once again. Now observe the pattern carefully. When the index was 0, combination is 0, 0. Index is 1, combination of 1, 0 which is equals to 1, and here coefficient of 1, 1 which is also equals to 1. Then when the index is 2, combination of 2, 0 which is equals to 1, combination of 2, 1 which is equals to 2, combination of 2, 2 which is equals to 1. So in this way we can write down any row of a Pascal triangle. So now if we will try to find out the expansion of a plus b raised to the power 7, we require the coefficients. Now if you have observed this pattern very carefully, you can easily find out what are the coefficients for a plus b raised to the power 7. The coefficients will be, when the index will be 7, the coefficients will be combination of 7, 0, combination of 7, 1, combination of 7, 2, combination of 7, 3, combination of 7, 4, combination of 7, 5, combination of 7, 6, and combination of 7, 7. These will be the coefficients for a plus b raised to the power 7. And taking help of these coefficients and the pattern which we have observed earlier, you can also write down the expansion for a plus b raised to the power 7. Now, again, if the question is to find out the expansion for a plus b raised to the power 20. Now what we will do? Now we will take the help of the binomial theorem. Because for binomial theorem, what we require, coefficients are already, we can find out using this pattern which we have observed here. So we are going to write down the expansion for a plus b raised to the power n, where n will be some positive integral value, and which will help us to find out any expansion like a plus b raised to the power 20 can be find out using the binomial theorem. So let us rewrite, or we'll say let us write down the statement for the binomial theorem. Okay, now let us try to find out the binomial expansion a plus b raised to the power n using the binomial theorem. The binomial theorem says expansion of a plus b raised to the power n, where n is some positive integral value, will be equals to combination of n, 0, a raised to the power n. The next coefficient will be combination of n, 1, a raised to the power n minus 1 into b, because now the degree of the first term will keep on decreasing and the degree of the second term will be keep on increasing. Next term will be combination of n, 2, a raised to the power n minus 2, b raised to the power 2, plus combination of n, 3, a raised to the power n minus 3 into b raised to the power 3, and so on, and the last term will be equals to combination of n, and b raised to the power n. Now this is the binomial expansion. Now using this binomial expansion, let us try to find out what will be the expansion of a plus 2 raised to the power 5. This will be equals to combination of 5, 0, a raised to the power 5 plus combination of 5, 1, a raised to the power 4, 2 raised to the power 1 plus combination of 5, 2, a raised to the power 3 and 2 raised to the power 2 plus combination of 5, 3, a raised to the power 2 and 2 raised to the power 3 plus combination of 5, 4, a raised to the power 1 and 2 raised to the power 4, and last term combination of 5, 5, 2 raised to the power 5. Now we will further simplify to get the expansion. Combination of 5, 0 will be equals to 1, so this will be equals to a raised to the power 5. Combination of 5, 1. This combination of 5, 1 can be written as 5 factorial upon 1 factorial into 4 factorial, which is equals to 5. So this will be equals to 5 a raised to the power 4 into 2 plus combination of 5, 2. If you will simplify further, it is 5 factorial, 2 factorial into 3 factorial, or it is 5 into 4 upon 2, that is equals to 10. So this is 10 a raised to the power 3 into 4 plus combination of 5, 3 is equals to combination of 5, 2. So this is also equals to 10 a raised to the power 2 into 8. Combination of 5, 4 and combination of 5, 1 is same. So this value will be equals to 5. 5 into a raised to into 2 raised to the power 4, that is 16. And combination of 5, 5 is equals to 1. So 2 raised to the power 5 is equals to 32. Now your final answer is a raised to the power 5 plus 10 into a raised to the power 4 plus 40 a raised to the power 3 plus 80 a raised to the power 2 plus 80 into a plus 32. So this is the expansion of a plus 2 raised to the power 5. In the same manner, if we wanted to expand like x square minus 1 upon x raised to the power 3 using a binomial expansion. Now let us see how we can expand x square minus 1 upon x raised to the power 3. Combination of 3 comma 0. Now the first term is x square raised to the power 3 plus combination of 3 comma 1 x square raised to the power 2 into minus 1 upon x raised to the power 1 plus combination of 3 comma 2 1 x square raised to the power 1 and minus 1 upon x raised to the power 2, and the last term combination of 3 comma 3 x square raised to the power 0 and minus 1 upon x raised to the power 3. Further we will simplify and the answer is combination of 3 comma 0 is equals to 1, so it will be x raised to the power 6 plus combination of 3 comma 1 we will calculate. Combination of 3 comma 1 is equals to 3 factorial, 1 factorial into 2 factorial, which is only equals to 3. So we will write here combination of 3 comma 1 is 3 x raised to the power 4 into minus 1 upon x plus combination of 3 comma 2 will be equals to again 3 into x raised to the power 2 and 1 upon x square. Combination of 3 comma 3 will be equals to 1, so it is minus 1 upon x raised to the power 3, and this answer if we will calculate finally it is x raised to the power 6 minus 3x raised to the power 3 plus 3 minus 1 upon x cube. So this is the final answer for x square minus 1 upon x raised to the power 3. So using the binomial theorem, we can find out the extension of a plus b raised to the power n. Now let us try to find out what is the answer for, or how can we show that 9 raised to the power n plus 1 minus 8n minus 9 is divisible by 64. We can take the help of mathematical induction for proving this question, but here we are going to prove this question using the binomial theorem. This 9 raised to the power n plus 1 can be written as 1 plus 8 raised to the power n plus 1. Now let us try to find out what is the extension of 1 plus 8 raised to the power n plus 1 using binomial theorem. So this will be equals to combination of n plus 1 comma 0 plus combination of n plus 1 comma 1 into 8 raised to the power 1 combination of n plus 1 comma 2 8 raised to the power 2 and so on, and your last term will be combination of n plus 1 comma n plus 1 and 8 raised to the power n plus 1. Now combination of n plus 1 comma 0 will be equals to 1. Combination of n plus 1 comma 1, let us try to find out. N plus 1 comma 1 will be equals to n plus 1 factorial upon 1 factorial into n factorial, or this will be equals to n plus 1 into n factorial upon n factorial, and the final answer is n plus 1. So this n plus 1 comma 1 will be equals to only n plus 1. So here we will write n plus 1 into 8, then combination of n plus 1 comma 2 8 raised to the power 2, combination of n plus 1 comma 3 8 raised to the power 3 and so on, and the last term combination of n plus 1 comma n plus 1 raised to the power n plus 1. Now further we will simplify. This is 1 plus 8n plus 8. In these remaining terms, we can see that 8 square is a common factor. So let us take 8 square outside. In bracket we have combination of n plus 1 comma 2 plus combination of n plus 1 comma 3 into 8 plus so on, and the last term combination of n plus 1 comma n plus 1 8 raised to the power n minus 1. Now 1 plus 8 9 is 8n plus 9 plus 64 into combination of n plus 1 comma 2 combination of n plus 1 comma 3 8 raised to the power 1 and so on, and the last term combination combination of n plus 1 comma n plus 1, 8 raised to the power n minus 1. Now let us bring these two terms on the other side, and this 1 plus 8 raised to the power n plus 1, we'll write it as 9 raised to the power n plus 1 minus 8 n minus 9, and this side what is left is 64 into combination of n plus 1 comma 2, combination of n plus 1 comma 3, combination of n plus 1 comma 4 into 8 square and so on, and combination of n plus 1 comma n plus 1, 8 raised to the power n minus 1. Now if you will observe here, this number is a multiple of 64, or we can say that 9 raised to the power n plus 1 minus 8 and minus 9 is divisible by 64 because one factor is 64 and the other factor is this one. So it was proved that 9 raised to the power n plus 1 minus 8 and minus 9 is also divisible by 64. And I hope you must have understood how to apply the binomial theorem in the expansions of a plus b raised to the power n, where n is some positive integral value. And I hope using these binomial theorem you can solve many more sums